All right, guys. It's Terry here again. What I'm going to be looking at in this video, I'm going to be looking at the solution to question 9 in the January 2021 paper, right? All right, so let's look at the first question here. Well, question 9, sorry, right? So this question is based on circle geometry, right? In the diagram below, A, B, C, D points on the circumference of a circle. So we have points A, B, C, and D, and they are on the circumference of a circle with center O, right? They said AOC is a diameter and BOD is a diameter. So we can see that from the diagram. Now this has stated the reason why ABC is 90 degrees. So ABC is actually this angle here, and they're saying that that is 90 degrees. So that's one of the rules when it comes to circle geometry, right? So the thing is, AC is a diameter, right? AC is a diameter, right? And because AC is a diameter, right, we can say that the angle subtended, right? Oh, that's not spell that word wrong there. Subtended. So the angle subtended by a diameter right on the circumference of a circle is 90 degrees, right? So that's essentially what they want. Any reasonable answer will work for 1 mark, right? You can also say the angle in a semicircle is 90 degrees, right? But essentially what we are saying is that on the two ends of the diameter, right, as A and C, if we try to make an angle by going towards the circumference, which is at B, you're going to get 90 degrees, right? So any reasonable answer will work here. This next one here now, determine, right? 1 second. Yeah, so determine the value of each of the following angles showing detailed working where necessary. So you want angle BAC. So let's see, where is BAC? So BAC is this angle here, which is what they call in 2P, right? That's called 2P. Now we have a triangle ABC, and we know that in a triangle, when you add up the angles in a triangle, you should get 180 degrees. So 2P plus this 3P here plus the 90 should give me 180, right? So let's look at that again, 2P plus 90. So this is 2P plus the 90 degree, right? Plus the 3P is equal to 180 degrees, right? So the sum of the interior angles of a triangle is equal to 180 degrees. So this is 2P plus 3P is going to give me 5P plus 90, and that's going to give me 180. So therefore 5P is equal to 180 minus 90. So 5P is going to equal to 180 minus 90 is going to give me 90, and therefore P is going to be equal to 90 divided by 5, and therefore P is going to be equal to 155, and this is 18 degrees. So P is 18, right? But that's not the answer for angle ABC. Eh? So angle BAC, right, is based on the diagram, it's actually 2P. That's this angle here. That's 2P. So therefore, this is going to be 2 multiplied by 18, right? And that's going to give me 36 degrees, right? That's going to give me 36 degrees. All right. Just give me a sec here. So in terms of the reason, right? In terms of the reasoning, basically what we're going to say is that the sum, you need to say this somewhere inside it. the sum of the interior angles of a triangle is 180 degrees, right? That's essentially what we use to solve this problem here. Let's look at the next one. This next one here is they want angle Q and they want a reason. Where is angle Q? So angle Q, right, is this angle here. This is angle Q. Now, there is a rule, right, a circle geometry rule that says the angles in the same segment are equal, right? Now, here's what's happening here. So this line here, this line BC, right, that's called a chord. That's what this line is here, right? It's a chord. Now, from that chord, you can create an angle by going to the circumference of the circle. So let's say at this point A here. Now you just worked out angle, that 2P, which was 36 degrees. So this here, we just worked this out and we got 36 degrees, right? So like I said, there's a rule that looks like this. If you have a circle, right, and you have a chord here, right, and we subtend or we form an angle on the circumference, and this angle here is theta, right, and we try to form another angle on the circumference using the same ends of that same chord, then this angle here is going to be the same, right? So therefore, we don't even have to calculate anything. Q has to be 36 degrees as well, right? So this here, so angle Q is equal to 36 degrees, right? And we can say that angles in the same segment are equal. So angles in the same segment are equal, right? And if you're not sure about the words, what you can do is just draw the diagram for them to show them that you know what you're talking about, right? So if I have a chord and I form an angle here, right, then this here is going to be the same angle. That's essentially the rule that I'm using here, right? Let's see, what's the next one? Oh, I guess they want angle R. What is angle R now? Where is the diagram? So we want angle R here now, right? As this angle here. Now, if you want to get angle R, we can look at this triangle here. Well, actually, there are multiple ways you can work this, right? One way we can do this is if we consider this triangle here, right? So if you consider this triangle here, right? Right? That triangle here, this is a radius, right? This is a radius and this is a radius, which means that this length and this length is the same. That's an isosceles triangle. So therefore, without even doing any calculation here, we can tell that this angle here is also 36 degrees, right? That angle is also 36 degrees. And that's by considering this isosceles triangle, right? There is another way as well. Now, if you notice, they said A, B, and DC are parallel, right? Meaning that this here and this here is parallel, right? So if this angle is 36, it means that this has to be 36. That's the alternate angle, right? So there are multiple ways you can answer this, but what they want, calculate the value of R. So R is equal to 36 degrees as well, right? So like I said, you can consider the isosceles triangle, and therefore Q has to be equal to R, which is 36 degrees. We can also use the fact that, so let me show you what I'm talking about, right? So this is AB, right? Let's see what a diagram looked like. And this was DC. So this is AB and this here is DC, right? And let's see this again. So we had B to D and that was 36. So B to D, right? And we had A to C, right? Now this angle here was 36 degrees, right? And this angle here, which is R, must also be 36 degrees, right? So DAC, make sure I tell you the correct thing, sorry, DCA, right, which is actually angle R, is alternate angle to BAC, right? So that's one way, that's another way you can look at getting the answer of 36. But there's only 1 mark, so we're not going to spend too much time on that. Now, the reason why I wanted to do this question had to do with the bearing question, right? So I've gotten numerous requests from students saying they have trouble with bearings, they're not sure how to answer these questions, right? Now, essentially, most bearing questions, you will either have to use the sine rule somewhere inside there or the cosine rule somewhere inside there. But the thing is, you have to remember how do we use the angles or the bearings that they're giving us, right? Now, let's look at part 1 here. So they said a harbor, right? H, from the harbor H, so this is H, right? So this is my harbor H, this red dot here. The bearing of 2 buoys, S and Q, are 185 and 311 respectively. Okay, so they said on the diagram, which shows the sketch of the information, insert the value of the angle marked QHS. So QHS. So what they want us to know, they're asking us here, what is this angle here, right? What is that angle? Now, we need to look at what they are saying with respect to the bearing, right? So let's look, I'm just going to draw a little sketch here to make sure you understand what's happening, right? So this point here is my H, right? And all right, so this is Q, this is S, and this here we know is my H. Now they said the bearing of, right, so we need to read this part carefully here, right? So the bearing of S from H, so the bearing of S. Now this is the point S here, and the bearing of S from H, which means I normally draw my north line at the point H, right? And that's 185 degrees, which means that this angle here is 185 degrees, which is what they've shown on the diagram. This makes sense, right? But they also said that the bearing of Q from H is 311. So again, you're starting at H, but the bearing that we're talking about here, let me use a different color so you see what I'm doing here. So you're measuring the next bearing, you're starting here, right? But what's happening here is that you're reaching as far as this point here. So that green line actually represents my 311 degrees, right? So obviously, if you want to get that angle they're asking us for here, which is this piece here, right? The question is asking for this piece here. All you need to do is to take 311 and subtract 185. That's all you need to do. So 311, right, minus 185, right? So 311 minus 185, and that should give me, let's see, minus 185, and you're going to get 126 degrees. So this here is 126 degrees, right? So you're getting 1 mark just for putting in this into your diagram. That's 126 degrees, right? 1 mark for that. Next thing they want us to do is to calculate the length QS. So we just worked out that angle. We got 126 degrees, right? And they also give us some lengths. If you go back to the question, they said Q is 5.4 kilometers from H. So Q is 5.4. So therefore, this length here is 5.4 kilometers. That's what this is, 5.4 kilometers. The next thing they told us is that S is 3.5 kilometers from H. So S is 3.5 kilometers from H. So this here is 3.5 kilometers, right? So as I said in the beginning, when it comes to bearings, we either have to use sine rule or cosine rule. Now they want us to figure out the distance QS. That is this length here, right? That's this length here they want us to work out. Now, if you have 2 sides and the angle between those 2 sides, then I have to use a cosine rule in order to do that. Now, I generally don't tell my students to learn off the formulas, right? Like C squared equal A squared plus B squared. I don't like to let them learn off that. What I try to tell them or how to learn it off, right? The side that is opposite the angle that I know, right? You're going to square that. So it's going to be, so we're going to say using the cosine rule. Right? We're going to say the side opposite the angle. So that's QS, right? So QS squared. So I'm writing the cosine rule in terms of what I know. So QS squared is equal to, you're going to square the other two sides and add them. So it's going to be 5.4 squared plus 3.5 squared, right? Minus, according to the formula, it's 2 by this number here, that's 5.4, multiplied by this number here, which is 3.5, multiplied by the cosine of the angle that we do know. So it's cos 126 degrees, right? So therefore QS squared, so we're going to do this little bit by little bit, right? So we're going to use this calculator here. This is typically what I use in class. 5.4 squared is going to give me 29.16. So you're going to put at 29.16 plus 3.5 squared. So working that out. So 3.5 squared, right? You're going to get 12.25. So this here is 12.25 minus, and what we're going to do, we're going to work out everything inside of that bracket there. So that is 2 multiplied by 5.4 multiplied by 3.5 multiplied by cos 126, cos 126, and you're going to get minus 22.22. So minus 22.22 minus 22.22. So therefore QS squared, right? So we're gonna just use the calculator to work that out now. So that is 29.16 plus 12.25, right? You have two minuses coming one after the other, so that's going to become a plus. So plus 22.22, and you're going to get 63.63. So 63.63. So therefore QS is going to be equal to the square root of 63.63. So QS is equal to, right? So we're using a calculator for that. So I'm going to just press second function square root, and I'm going to get 7.98, right? So 7.98 kilometers, right? So 7.98. Right? So let's go on to the next part now. So they want to calculate the bearing of S from Q, the bearing of S from Q. Now, how you interpret these questions, you see the from is where we're going to put our north line. So Q in this case is here. So we're going to put a north line here, right? Because we need to understand what bearing they're actually asking us for. Now, you know, calculate bearing of S. So the bearing of S, you have to draw a line from Q to S, right? That's this line here we're talking about here, right? This is a line joining Q and S, but my north line is being drawn from Q. So the bearing that they're asking us for here is this bearing. They want to know this angle here. That's what we're really trying to figure out, right? We need to figure out that angle. Now, let's put in the angles that we do know on the diagram. So if I were you, if I were working this question in the exam, I'll put in everything that I know. So I know that this angle here is 126 degrees, right? So if we know this angle is 126 degrees and you know this one here is 185, you could work out this angle here, right? So let me call that, I'm just going to give it some labels to make our life easier. So that angle there, that angle A is actually equal to, remember, one complete circle is 360 degrees. So it's 360 minus 126 degrees plus the 185, because remember, complete revolution is 360, right? So let's work that out here. So that is 360 degrees minus, open brackets, 126 plus 185, close brackets, equal, you're going to get 49 degrees, right? So this angle here is 49 degrees, right? So this here is 49 degrees. Now, one of the things that we need to make use of in some of these questions is that the north lines are always parallel, right? So we're making use of parallel lines. So if this angle is 49 degrees, let's use a different color here, right? I can work out this angle here, right? That green part there. You could work out this part here, right? That green part, because that green angle and this angle A, they are what we call co-interior angles. What that means is that when I add them up, I should get 180, right? So therefore, to get this angle here, the green one, it's going to be 180 degrees minus 49 degrees, right? So 180 minus 49 is what? So 180 minus 49 degrees is equal to 131. So this angle here, right, is 131 degrees, right? Now, we know this angle now. So all you really need to do in order to finish this question, we need to just work out this angle here. We need to work out this small angle here. If you know this small angle, then it's just a matter of taking that angle and add it to 131, and that'll be my answer, right? So here's what I'm going to do. Let's look at the dimensions that we do know from the question, right? We know that 5.4, 3.5. So this here is 5.4 kilometers. This here is 3.5 kilometers, right? And what do we know again? That's 126. We also know that is 7.98. This here is 7.9, right? So like I told you guys, we either have to use the sine rule or the cosine rule, or a combination of both, right? Now, when you use the cosine rule, you must have two sides and one angle, or two angles and one side. So in this case, I'm going to make use of the sine rule here. So using the sine rule, right? Now the sine rule looks like this. We need to take a length divided by the sine of the angle opposite that length. So let's say I use this one here. Let's say I'm using the 7.98. The angle opposite to that is the 126. So 7.98 divided by sine 126 degrees, right, is equal to, remember you're trying to work out this piece here. This angle is what you need to figure out. So I have to use this length here, which is opposite that. So this is 3.5 divided by sine of the angle that I don't know. Let's call that angle, let's give it a label. Let's call it theta, sine theta. So what I'm doing, I'm trying to solve for theta. And if I solve for theta, then I'm going to just add that to 131. And that will be my final answer, right? So when you have a problem like this, all you do is cross multiply. So this is 7.98 multiplied by sine theta, right, is equal to 3.5 multiplied by sine 126, right? So therefore sine theta, you don't need to simplify anything as yet, right? You can do all of this in a calculator. So 3.5 multiplied by sine 126 degrees divided by 7.98. So therefore sine theta, use a calculator for that part, right? So we're going to say 3.5 multiplied by sine 126, right, divided by 7.98, and what we're going to get is 0.355. 0.355. So therefore theta is equal to arc sine, so we write it like this, 0.355. So therefore theta is equal to, so second function sine, and that's going to give me an angle of 20 point, we rounded up that to the nearest 0.1, right? So that's 20.8 degrees. So this here is 20.8 degrees. So my answer, right, which is the bearing of S from Q, the bearing of S from Q, right, is simply going to be equal to the 131, right, degrees plus the 20.8 degrees, right? And that's going to give me what? 151.8 degrees, right? 151.8 degrees, right? So that's my angle here. That's the bearing that I'm looking for, right? So that takes care of question 9 in the January 2021 paper, right? And like I said, guys, I do give maths, chemistry, physics online classes, and I will be given AdMats from August this year, right? So those students who are entering Form 4, right? I can be contacted. You can send me a WhatsApp at this number, right? And please hit like and subscribe to my channel, right? Take care, guys.